Yesterday we completed the microwave communication, and today we're going to learn about the infrared communication. Let's see the infrared communication. And infrared transmission is the wireless technology used for the communications over a short range. So infrared cannot travel a long distance. So why? It's used the low high frequency as compared to this radio wave that infrared is a very high frequency, and it cannot penetrate wall or a building or any types of obstacle. That's why that the frequency range is the 300 gigahertz to the 400 terahertz. Okay, terahertz. So the frequency is a very high as compared to this microwave wave. So that's why we are in communication, that the applications also in the short range. It uses short range communications such as data transfer between the cell phones. In our technology of these microphones like a Nokia or any other mobile phones, it's having this IR transmissions. Okay, we can transmit the uh, data to the in our old technology mobile phone, but right now it's not longer exists in our smartphone. We are having this short range communications like a Bluetooth and other communications, Wi-Fi data transmission, and we are still using in the TV remote operations, also TV remote control, that it's used this IR communications. Why it's used this IR communications in the TV remote control? Because of the obstacle and all. Say suppose if we use a radio wave in the remote control, then this radio can penetrate wall or any obstacles. Then it's not for controlling the TV. Means that we can, if you control the if you press the remote control, then it cannot control only the particular TV, then it can control another TV also, which is located in the another rooms or in another building. So it can penetrate the wall. So that's why we are using this is still using this IR communications to communicate the particular room only. Data transfer between the computer and the cell phones reside in the same closed area. That's why it's very clear that it can controls in a closed area, room, buildings. Okay, so we are using this uh, IR for the remote control, and characteristics of the infrared is that it supports high bandwidth, and hence the data rate will be a very high. So this is the higher bandwidth, and it can achieve high rate data transmissions. Okay, infrared wave cannot penetrate the wall. That's clear. Therefore, the infrared communications is one room cannot be interrupted by okay, that's it cannot penetrate the wall. That's why it's effective in the closed room, closed area only. And infrared communications provide better security with the minimum interference. So the interference is the very less as compared to this as compared to other communication. So it's using the very high frequency. Infrared communications is unreliable outside the buildings because of the sun ray will interfere with the infrared wave. So here we have to remember this point. This point is very important, that this is susceptible by the sun ray, electroviolet ray. Okay, violet rays that intercept the signals infrared wave. Okay, that's not reliable in the outdoor. So here, this picture depict this one. In a human eye, we cannot detect these infrared signals. And if you capture with your mobile phone, then you can see the infrared light, which is generated by the uh, infrared transmitter located inside the mobile phone. And moreover, in our old technology mobile phone also we have infrared light transmitters, and some MI phone, okay, Note 3, Note 4, Note 5, all those things coming up with this infrared communication, so we can use as a remote control. Okay, our mobile phone we can use as a remote control also. Okay, these are the things in the infrared. Let's see, in our physics, in the class 10 and 11, 12 also, that physics foundation, all this object does not have a color. Country may thea object rekin color ni lo tika physics sa chuan ani. Eng vang in nge color ani lo kan ti chuan. An mani in eng pek chuat in a source of light object hin ani lo ani. Amaro chu color angin kan mu thei si lai takahi engetinge chan kan ti chuan. It reflects the light. Object and so reflect light. More light and reflector. Chu wang chuan unreflect light azir khan kan mitchunga retina khan color classification light aron du danzir khan color classification aron siama chu kan thluakin alo interpreta chuta chon color kan hmuangin kan hrin ta ni chu physics ai ta ni fundamental of physics a chuan chu he fundamental sa hi chian ve theina lai chan pakhat chu atinan sana chon absence of light. At night you cannot see any color, you'll see only blackout. But if you turn on the light, then you can see the color, okay, based on the intensity, the lumens of the light. If the lumens is high, then it become brighter and brighter, then you can see the color, okay, in the presence of light. But if there is no light in a room or any environment in the ambient light, there is no ambient light, then it's completely black, okay. So it's black out the environment. That one more point is that if you use the camera at night with the absence of light, then you can capture the photo in a black and white if it is infrared. Hey, so the panzana engan muthei kan ti san chu infrared kha unload depict thei tlak many zo hey zo te hemi mid mo a vertical zo o mangchi ho kamo light signal de lo khan infrared kha an muthei ta he ba pe pon ne infrared zana khan zana chuching chozong chi ho mo zana chozong chi ho khan infrared mangkhan infrared light mangkhan infrared signal mangkhan in zana thilan muthei ti nan ta ni hey camera te po ni ta infrared camera te chuan zana thla kan na thea thim eng ang po ni salam infrared signal khan in e avathon chua khan bounce back aron ni ta ni aron reflect back ta infrared signal kha aron reflect back ta aron chunde ta chu aron chhun let infrared bounce back signal chu infrared sensor khan alo capture a ta chuanin I light kha kan lo hmu thei light alo hmu a ta chuan light ro receive dana zir khan sorry light kan ti infrared signal kha chu infrared signal alo receive dan asir chuanin I image kha lo inform me thin ta ni. Okay, this is the technique of this infrared. It's used very high frequencies. It's used starting from this 300 gigahertz to this 400 uh, terahertz. Okay. Okay, this is the example of the infrared communications. This is the wireless communications under this also. Let me recap the wireless communication first before going to the next point. Under this wireless communications, we have three types of communications. One is the radio wave. Okay, it's ranging from the 3 kilohertz to the 1 kilohertz, and then it's used in the radio communication. And also it's transmit in the electromagnetic wave from the antenna and receiver antenna. There are two types of transmission: omnidirectional and directional communication. Under this radio communications, we have ground propagations and space propagation. Under this ground propagations, it can travels above the earth, okay, above the ground. So AM, FM, short wave, all these things in the ground propagations, it's transmit in a ground propagate. In the space propagations, we have a layer of atmosphere here, atmosphere, ionosphere, lithosphere, other sorts of things are there. So ionosphere is a mixture of ions and gas. That's why can reflect it back the radio wave. And moreover, that under this communications, we are using this cellular network and FM and other communications. Okay, walkie-talkie and all. Next point is microwave. Microwave, under this microwave we have terrestrial and satellite. Terrestrial microwave, we have antenna. This use the high frequency as compared to the radio wave, that it travels in the 1 gigahertz to this 1000 gigahertz. That very high frequencies cannot penetrate while mountain, building or anything. This is need the line of sight. Okay, it's need the line of sight. So in between this, if there's some obstacle, then it cannot penetrate this one. So an antenna needed to mount it at the tower of the at the top of the buildings or at the top of the mountain to overcome the obstacles. Okay. And last but the least, this in the microwave communications, we are having this infrared. Just now we are saying that it transmits in the 300 gigahertz to the 400 gigahertz. So it cannot penetrate wall or building anything. Then it's used in the cell phone and then remote control. Okay, this is a very high speed communications and also unreliable because of this susceptible by this ultraviolet ray. Okay, these are the things in this wireless communication. Let's move on to this analog and digital transmissions. What is analog transmission and what is digital transmissions? Let's see analog transmission and analog signals, also known as the waveform. I hope that you already knows that this analog communications, this is the analog, okay, sine wave. Last class I already explained that this sine wave, that it's complete the one cycle. Okay, this is the cycle starting from 0 to 90 degree, 180 degree, 270 degree, 360 degree. 360 degree is the complete cycle. Okay, in 1 second it can complete a multiple of cycles. Then this is measured in terms of what frequency measurement is called hertz. Okay, let's see here, this in between this is 1 second. Okay, if it is this 1 second, then the hertz is 2. Okay, hertz is 2. So it can generate, it can complete 2 cycles in a 1 second. But if this 1 seconds in between this one, then the hertz is 1 hertz, means it can complete in a it can complete 1 cycle in seconds. So hertz is measured the cycle per seconds. Okay, cycle per seconds. So analog transmissions is characterized by using this continuous variables along both amplitude and frequency. So we have our amplitude and the frequency in this analog transmission. In the case of telephony, when we speak into a handset or our video, sorry, converted into a current or voltage fluctuation. So microphone, I hope that you already know that this is the converter of this vocal length or wavelength into this electrical signals. Okay, it's converted into the electrical signals in our telephone, smartphone, mobile phone, or maybe a conventional amplifiers. We need a microphone. Let's see here. Telephone microphone condition microphone here diaphragm hey again condenser mic kan ti te chi sang khom te ta ni chung ho chu eng wangin ya kha voice kha lo pick up te kan ti chuan between variant chuan in vocal box kan ne ya no kan o ti chuan ka vocal box ka chu vocal box chuan nghe ni ron siap ka ti chung kan tong re re hian kan lei le kan vocal box hian in vibration a siam chuak ta ni vibrate kan ti re chuan analog kan ni chu mo vibration a siam ta ni kan tong ri khan vibration a siam mo chu vibration a chu era mo boruak space a aron vibrate ta ni boruak aron ti che ti na ni chu chu vibration chuan eng wangin nge ka tonga kha aria kha ilo hriat thei tuna po hian again Google Meet mangin class kan nei ta ni ta chuan in ka tonga hi keima laptop pa microphone hian alo pick up ta ni khami vibration aka condenser mic chu khan alo pick up chu converted into this analog signal in the form of electrical ani alo convert ani chu hemi digital communication akhana ron transfer ta tuna khanin I mobile phone poni me the I laptop poni me the chu aron kal thing tan khami digital format du ko sungai thlak om lo no ngai thadon poni la om je nei lo chu eng tin nge I lo hriat thei si kan ti chuan I laptop ate I mobile phone ate kha signal kha electrical signal digital signal kha is needed to convert it back into this waveform. Okay, vibration chu speaker khana ron pe chuk le ta ni mo diaphragm pang khan speaker kha ron ti chata earphone pon mi the I laptop pon mi the mo I laptop sound system pon mi the ya plus yani speaker pon mi the yani computer speaker pon mi the to the speaker chuan in vibration na ron siam ta ni che ka back and forth the vibration ka chu back and forth vibration chuan air kan in thil che aron siam ta chu thil che a chu mihring hi analog in nature kan ti theng chu kan thil mu dan te kan thil hriat dan hemi kan receptor kan ting kan sense organ kan ti kha kan sense organ system kan mihring de si lok tai la mit kha kan sense organ pakhat chuan ta ni mit thil kan to mo kha lai ta ron lu ta a chu kan mit chung retina khanin achunga hen retina chunga hianin nei kan nerve free nen khan kan mit free nerve nen khan in zo bat thua kan zom tan chu light ron lut dan zer khan nerve khan in kan thua ka signal lo ta chu signal a mu dan a zer chuan color identification kha kan nei thei tan ka chu sense organ pakat no kan thil mu mo kan perspective thil kan mu dan a zer khan tan chu lo le chuan heat amo khati ang chi rang rang thil bulani mo thil riam ani mo kan hre the chu kan skin ani ta ni skin a kha kan sense organ pakhat chun ta ni kan vun mo kan vun ina thil a to dan zir khan kan nerve ina thua ka signal a pek dan khom le ta ni chu lo le a chuan hey test te poni a kan ka mo khami po khal ni le thei ta ti chu lo chon kan na mo smell thil rim kan hre the la adang le chon kan beng ani ve thung ta ni kan beng a hianin ear drum lo ta ni beng dar kan ti kha chu beng dar chu thil soi po kha heta ka call in a lo convert ta electrical signal in lo convert ta chu digital communication aron transmitter ilo hong ve a google meet ilo join ve a chu google meet ilo join ve a tang chuan i system khan kha voice digitize kha analog formation in speaker aron pe chuk ta chu speaker in a vibration manga boro ka ron ti chen bang khan ear drum kha ron no chetani chu anor chet dana zir chuanin i inner khan i thua ka signal a beta chu signal ape ka chu alo decode le ta chu om zero kha thei tan ri lo fia tong i lo fia chu ri le tong i hriat atang chuan i thluak chuanin i taksa a nervous system hangin instruction ape a chumi instruction apek dan phang chuan che in ikalin mo i thluak a call chi ni chuan i lo memorize a i lo chin chia ta ni kha kan system kal dan phang chu alon ta ni analog kan soi tel pa kan soi tel du chu hilaya our voice is converted into a current or voltage fluctuation. This fluctuation is a current or analog transmissions over an actual voice pattern. Khamia anitani. To transmit analog signals effectively, we need to define the frequency in which is operated. Intemporarily, the usual voice frequency band ranges from approximately 300 Hz to the 40 Hz. And so the network provides the phone company will allocate the bandwidth around this 3000 Hz for voice transmission. Aum je chu mishing hianin again kan bengina alo process thei china kha aum betani human audible frequency machine again frequency kan hiat thei china khaum ta ni a hniam lampang le sang lampang a khan mo kan lo sound kan lo pick up thei chen 20 Hz to the 20 kilohertz in karaka machine pa nga ina kan lo hiat thei china ni ta a ran tei chon ke ni a nan khesang de thei ni these pets or any animals, okay, it can receive more than our frequency. Kan tiang chu atinan ui te zo te mo kan ri hriat thei na ai sangin an rian hriat thei a kan hriat thei na ai niam te pon rian hriat thei ni hey mosquito repellent te lo chuanin rat repellents kan an tih chi te po frequency sang taka kha generate thei kha han siam chuak ta chu chu an ni tan chuan a beng cheng lu tuk to ta ni ma se mi hring chuan kan hre phak mi lo kha ria kha asan chu kan ri hriat thei na chin pia lam pangai tlat kha ri sang frequency kha a generate na khol te kha han siam chuak ta chu ta chuan hei chuk chu te mo sazu te mo mosquito mo khang ho kha ni a repellent mo anom thei lo tur khop khan frequency sang a generate thei kha kan sei tel du ta chu human audible range kha kan sei tel lo kan helai kan sei ta kan chu wang chuan in that's why in our telephone and other things that the voice are transmitted in the form of this within this range of this 4000 hertz for audibles. Okay, because of the limitation bandwidth long facilities have they cannot support a high speed transmission, so cannot support to transmit the high speed in this analog transmission. I hope that you clear this analog communication. Let's move on to this digital communications. Before this, analog is very complex very complex in this communication. Let me open one more point. Analog communications. So here in this analog communication, we have a frequency and all this frequency and other things. Frequency carrier and frequency. It depend on the analog analog sorry in the analog we it's divided into two